Hello everyone! This video would focus on graphing cube root equation in vertex form, and this is the third part. In this part, the absolute value of a is greater than 1. Before we go further, please feel free to check out the description box below for the link of the other series of topics related to graphing cube root equation in vertex form. Before we jump into this example right here, let's have a review on the basics of cube root equation in vertex form. We remember that the graphing form or the vertex form of a cube root equation is given in an equation y equals a cube root of x minus h plus k. Now let's investigate the effects of a, h, and k to the graph. Now we remember that if a is positive, one of the two branches rises to the right. So as you can see here, this end of the graph rises to the right. Now, if we change the value of a to 0, so please notice that if a is 0, I'm changing the value to 0 right now. If a is 0, the graph is a horizontal line. So as you can see here, the graph is a horizontal line. On the other hand, if a is negative, one of the branches, there are two branches, so one of the branches is falling to the right. So this side right here is falling to the right. Again, that if our a is negative. On the other hand, the closer the value of a is to 0, as you can see here, we started from negative 10. We're making it closer to 0. We're moving it all the way down to 0. You can see that the graph is horizontally compressed. So until to such a point that if a is 0, the graph is totally compressed, forming a horizontal line. And that is also the same thing on the other side. So starting from the value of a, which is 10, once it goes to 0 or the graph gets closer to 0, the graph again becomes horizontally compressed. That means the graph becomes more horizontal in shape. So it is horizontally compressed. On the contrary, the farther the value of a is from 0, that means from 0 we go higher value all the way to 10, the more that it is vertically stretched. So as you can see, it becomes more vertical as we go farther from 0. And that is also the same thing for the other side. So you start from 0, we go away from 0 towards negative 10. Again, the graph will become vertically stretched. That means, on the contrary, the farther the value of a is from 0, that means from 0 we go higher value all the way to 10, the more that it is vertically stretched. So as you can see, it becomes more vertical as we go farther from 0. And that is also the same thing for the other side. So you start from 0, we go away from 0 towards negative 10. Again, the graph will become vertically stretched. That means its shape becomes more vertical. Now, we also remember that the coordinates h, k is the vertex of the graph, or we call this as the locator point, where our h translates the graph left or right, and our k translates the graph up or down. So these are the basic information about the graph of a cube root equation. Okay, so let's go over the problem here. The first step here, in order that we can sketch a graph for this equation, is to determine the vertex or the locator point. So I'm going to go ahead and write that down here. We remember that the coordinate of the vertex or locator point is hk. This represents the h, this represents the k. To write the coordinate, we switch this, so that would be a negative 1, and we keep this, that would be a negative 4. So our vertex is sitting at negative 1, negative 4. The second step is to create and complete the table of values. I'm going to go ahead and draw the table of values down here. In this table of values, we are supposed to write the vertex or locator point in the middle. So this would be for -1 and -4. So we go ahead and determine the rest of them. So I can go ahead and write -2 and -3 here. I go the other way. This would be 0 and 1. Our next task is to show the work in order that we can determine the rest of the values for y here that are blanks. So what are we going to do is we will use this value of x that we wrote in this table here. We plug it into the x of the equation and then we solve for y. So for example, if we want the value for y here, I go ahead and write x is equals to 0 and I will put 0 into the x here so that our equation would come out. Okay, so what I did here again was I plugged in the x there and I will solve this right side of the equation. So that would be 2 cube root of 0 plus 1 is 1 minus 4. 2, the cube root of 1 is 1 minus 4. So then this is 2 minus 4. This comes out -2. So the value that we have here would be -2. Now I will show you the work when x is -2 and determine what the y value is. Okay, the value that we got here is -6. So what I did was we have a -2 plus 1 is -1. The cube root of -1 is -1. 2 times -1 is -2. -2 minus 4 is -6. So we're going to determine the value for y when x is 1 and x is -3. I'm going to show the work down here. Okay, so I've shown the work down here for all of the other blank boxes and we have completed the table. That means we can move on to the third step. The third step is to sketch the graph. So we're going to start with the vertex. -1, it's going to go to -4. So this is the vertex down here. -2 goes to -6. -2 goes to -6. It's going to go down here. And then we have -3 goes to -6.52. So 6, this is 7. So halfway between that. And then we have 0 goes to -2. This goes down here. And then 1 goes to 1.48 negative. So 1 goes to -1.48. So it should sit somewhere around here. So we're now ready to sketch the graph. So this is the graph of this equation that we have up there. Now, please notice that both ends of this graph would go towards the positive infinity and the negative infinity on the left. And then it goes up to positive infinity and it goes down to negative infinity. And so that means both domain and range would be all real numbers. I'm going to go ahead and write that up here. Now, let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, we go over the problem here. Again, the first step is to determine the vertex or the locator point. I'm going to go ahead and write it down here. Okay, our vertex or locator point is located as +1, 3. Remember, we switch. This becomes a positive because it's a -1. And then +3, we keep it, so that's a +3. So our vertex is sitting at 1, 3. The next step is to create and complete the table of values. I'm going to go ahead and draw the table of values down here. Okay, so what I did was I placed the vertex or locator point in the middle of the blank boxes and then I put in values for x. And so we are going to show the work in order that we can determine the rest of these blank y values here. What are we going to do again is to plug these values into the x so that we can solve for y. I'm going to show the work on the side right here. Okay, so what I did here was that I determined or the value of y when x is 0. So what I did is I plugged it in. 0 minus 1 is negative 1. The cube root of negative 1 is negative 1. So negative 2 times negative 1 is positive 2 plus 3 is 5. When we have a positive 2 right here, what I did was I plugged in the 2 to the x. So 2 minus 1 is positive 1. The cube root of 1 is 1. So negative 2 times 1 is negative 2 plus 3 is positive 1. And I'm going to show the work for the rest of these when x is negative 1 and x is 3 on the side down here. Okay, so we've completed the table of values and we have the work down on the side here. So our next step is to sketch the graph. So first we are going to draw or plot the vertex that would be on 1 and 3. So it's going to go all the way up here. That's 1 and 3. That's where the vertex is. On 0, it's going to be on 5. And then on negative 1, it's going to be on 5.52. So that should be somewhere around here. And we draw the other way, so that would be 2 goes with 1, so it's going to go here. And then we have 3 goes to 0.48, so that should be somewhere around here. And so we're now ready to sketch the graph. Okay, if you notice, both tail ends of this graph would go infinitely towards the right and towards the left. It's going to go infinitely up and infinitely down. This tells us that our domain and range for this would be all real numbers. I'm going to go ahead and write it down here. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!